Okay, so we have a rather large problem with this one. If we want to get rid of that square root of 5, we need to multiply it by a square root of 5. But the problem is, if we just multiply our numerator and denominator by the square root of 5, remember these are assumed to be in parentheses, so we would have to distribute here and here, which isn't a problem on the top, but on the bottom we're going to get 5, that's what the square root of 5 times 5 is, plus 3 square root 5. We still have that in our denominator. So what you might be thinking is, well, what if I could just square the square root? That's kind of what I think of, but you can't square the numerator and denominator of a fraction and have it still be equivalent. I mean, think of 2/3. If you square the 2 and the 3, you get 4/9, so that really doesn't work. So what we want to be able to do is we're going to have to multiply by another binomial, as it turns out. And if you looked at the hint, you might have figured this out on your own. The whole idea is that we need to multiply by a binomial that will not have any square root of 5s in there. So we need to multiply the square root of 5. Definitely, that's got to be a part of it. But the problem is, no matter what we put at the end there, we're always going to have these little middle terms with the square root of 5 in them. Those will be like terms in the middle, unless you can multiply by a binomial that will not create any middle terms. Okay? Think of difference of squares rule. See, if we multiply by this, both of the terms that contain a square root of 5 are going to cancel out in our denominator. If you don't believe me, multiply it all out. Okay, we get 5, that's what the square root of 5 times 5 is, minus 3 square root of 5, plus 3 square root of 5, minus 9. Oh, look, those cancel out. That's awesome. So we no longer have that problem in our denominator. Now in our numerator, we won't be so lucky. We will still have a square root there, but that's okay. We can still, we don't mind it if it's in our numerator. That's okay. So what we get there is square root of 5 times 5 is 5, minus 3 square root 5, plus 7 square root 5, and then minus 21. So after you combine all of your like terms, on the bottom we get a negative 4. On the top we get negative 25. Oh, I'm sorry, not negative 25. That was silly of me. 5 minus 21 is definitely not that. It is negative 16. And then we get positive 4 square root 5. Now it's up to you, but since I see 16 and 4 on top and negative 4 on the bottom, I'm going to, you can kind of look at it two ways. I'm going to look at it as distributing that negative 4, dividing both of those numbers. Negative 16 divided by negative 4 is 4, and 4 square root of 5 divided by negative 4 is just negative square root of 5. If you don't see how I got that, think of factoring out a GCF of negative 4 here, just like you would with a polynomial. And that's what you'd get. And then the negative 4s get to cancel, which is awesome. Okay, it's called multiplying by the conjugate. Okay, the conjugates are those same expressions with little opposite symbols, so like square root of 5 plus 3, and then same thing with a minus 3. So that's how you have to get rid of square roots when addition or subtraction is involved in your denominator. You got to multiply by the same binomial, but with the opposite symbol in the middle.